When working with the DMX installation, there are two types of limitations to keep in mind. Physical limits, related to cabling and the number of devices on each line, and data limits, related to the amount of information in the universe. In this video, we cover the limits related to data in a DMX universe. Data is sent on a DMX line as a sequence of frames, each of which contains 512 channel values, between 0 and 255. This group of 512 channel values is referred to as a universe. A controller typically sends 33 of these frames every second. Every device on the DMX line receives the same sequence of frames sent down the line by the transmitter. There's no way of knowing what each channel value represents just from observing the DMX frame. Each device observes the channels it's programmed to follow, responding to channel values according to the mode it's been set to. The device ignores channels it's not being programmed to follow. The number of DMX channels a device requires is referred to as its footprint. Dimmers typically use just one channel, where 0 is off and 255 is full intensity, whereas a colour fixture with red, green and blue channels might use 3 channels of DMX, one for each emitter. If a fixture requires more precise control than the range between 0 and 255, 2 channels can be combined to utilise what's called 16-bit control. A second channel introduces 255 additional steps of control between each of the original channel's values. Many fixtures offer multiple modes, altering the fixture's footprint depending on the control level required. When setting up a device, it needs to know which channels it should observe. The device knows from its mode, and therefore its footprint, how many subsequent addresses it should observe. This first address is called the start address. Say we have an installation with 4 RGB fixtures. Each fixture has a footprint of 3. If all 4 fixtures have their start address set to 1, they'll all follow channel 1 for red intensity, channel 2 for green intensity, and channel 3 for blue intensity. To set the lights to orange, the controller can send the correct data. All fixtures have the same start address, so will all do the same thing. For individual control, each fixture needs its own unique set of channels. To do this, we need to set the fixtures to unique start addresses, so that they can receive data for the required colour. This process is called addressing. Different types of fixtures can be connected to the same DMX line. Regardless of the type of fixture being used, it's important that their channels do not overlap. The number of fixtures which can be controlled by a single DMX universe of 512 channels depends on the type of fixtures being used and the mode they're set to. A DMX universe containing only RGB fixtures with a footprint of 3 can control up to 170 of these fixtures. If the same fixtures were set to 16-bit mode and required 6 channels of control, 85 could be controlled by a single universe of DMX. Some fixtures contain multiple elements which can be controlled individually. Some of these come close to consuming a whole universe of DMX. The examples pictured here have so many fixtures that multiple DMX universes are required to control them all individually. In the next video, we'll look at DMX in practice.